Hello, good evening. Welcome to the stream, and I hope you have done well in your term 1 exams. And now is the time that you people need to prepare for the term 2 exams. Term 2 exams are going to be held by the CBSE sometime in March or April. The dates are yet to be decided by CBSE, but whenever the dates will come out, I'm surely going to tell you in this channel. But what we are going to do is we are going to start preparing for the term 2 exams from right now. And for that, it is very essential that we start picking up each of the topics that are coming in the syllabus and we start preparing for them one by one. So we'll pick up one topic, a part of one topic, and we'll prepare for that so that whenever the exam comes, we keep preparing side by side so we are prepared by the time the exams are there. Right. So in today's topic we are going to discuss quadratic equations. Now the chapter of quadratic equations is actually divided into three parts, where the first part is about identification of quadratic equations and factorization of quadratic equations. The second part is going to be about the completing the square method and the quadratic formula, and the third part is about the nature of the roots, where we talk about discriminant and all. So this is what we are going to cover, so it will probably be covered in 2 or 3 streams, so it's not possible to cover the entire chapter in one stream only. The way I'm going to go about it is that I have got some sample problems which I think are most likely to come in the board exam, so I've chosen those questions and we are going to solve them on screen. But I don't want it to be a just watch session, so I want it to be interactive, where you people as the audience also need to participate in it, so that whatever questions I show on the screen you should be able to solve it. And I would prefer if you are able to send in your answers before I give the real answer or the actual answer on the screen. So it will be very helpful for me and I will also enjoy it. So that is how we are going to go about it. Plus it is not only about my questions, because I would prefer that it is this stream is done for you people. It is not beneficial to me, it is beneficial to you people, and that is why it is more important that you people understand how what I'm going through, and wherever you think that you are not able to understand something or you want me to explain some part of it again, you can stop me right there. Not by speaking, because your voice is not going to come on the stream, but you can leave a comment in the chat, and when you leave a comment in the chat I'll come to know about it and I'll go over that part again so that you people understand. Second thing I want, it is not only about the questions that I have chosen. If in case you find a question that you think is difficult for you to solve or you don't know how to solve it, then you can write that question in the chat again, and I'll make sure that I cover that question and give you the solution for it. Right, so let us jump into the topic straight away. I don't want to make it a very long stream, so probably I'm planning to finish within an hour and a half. So by it's 5 o'clock right now, so by 6:30 I think we should be done. But I need proper participation from you, so that in case you are interactive, I would also like it, and probably you guys would also like it. So let's start. So basically the first question that I have, so like I said, we are going to talk about quadratic equations today, and most of it is about we'll just brush through a little about the identification of quadratic equations, but most of the chapter is about factorization of quadratic equations, and I'm going to explain it in such a way that you will never find factorization a challenge. It is going to become a child's play for you. लेफ्ट हैंड का खेल जैसे बोलते हैं ना, वो हो जाएगा. It is going to be child's play. It is going to be wonderful experience. So just go along with me and make sure that you understand everything that we are doing. Right, so let me make the screen a little bigger. I think this should be better. And right, so when we do the questions, the first thing that I'm going to, before the questions, I would like to discuss about the concept that we are talking about today. So the concept that is there is about, the first concept is about identifying quadratic equations. Now, about identifying quadratic equations, a general quadratic equation can be written in the form ax square plus bx plus c is equal to 0, where x is the variable and a, b and c are real numbers. So let me write it here that a, b, c, they belong to real numbers. Right, so they belong to real numbers, so which means what are real numbers? They could be decimals, they could be rationals, they could be irrational numbers, they are also real numbers, they could be integers, they could be negative integers also, whole numbers. Everything is possible. B and C can take any value of any real value, whereas there is one condition that A should not be equal to 0. A can take any real value but not 0. So that is the only condition. And how to recognize a quadratic equation, how to identify a quadratic equation, the way is that you look at the variable has got a highest power of 2. So the power, if the power of the variable is 3, or if it is 4 or 2.5 or anything more than 2, then it is not a quadratic equation. So you see the variable figures here in 3 places. Actually one is hidden. So the first is it has a power of 2. Second, in the second term it has got a power of 1, and in the third term also the variable is there, just that it is hidden, and it has a power of 0. So x to the power 0 becomes 1. That is why we don't see x in the equation. So a quadratic equation like 3x square plus 6x minus 9 is equal to 0 is a quadratic equation, because x is the variable here and it has got a highest power of 2. 6 upon 6x, it has got a power of 1, and c, which is minus 9, is the constant term. So this is what happens in a quadratic equation. This is how we identify quadratic equation. 1 upon x square is not a quadratic equation, because this can then be written as x minus 2, x to the power minus 2, and x to the power minus 2, it cannot be the power cannot be negative, so it has to be positive real positive integers. The power of the x should be positive integers and it should not exceed 2. Right, and the third thing, root of x is equal to root of x square. I would say root of x square or root of x is equal to 4 is also not a quadratic equation, because root of x can then be written as x to the power 1 by 2, and 1 by 2 is not an integer. It is positive but it is not an integer, and therefore this is not a quadratic equation. We'll go over some questions and you'll get a hint of it, an idea of it, how to do it. Then how to prove that a number is the solution. So for this excuse me, for this let me take an example. So let me take the quadratic equation as x square minus 5x plus 6 is equal to 0. Now we want to check if negative 2 and if 2 and 3 are the roots of the solution, roots of the equation or not. What do you mean by roots? Roots means solution. What do you mean by solution? Solution means that any value of the variable for which the left hand side and the right hand side become the same is called the solution of the thing. Or I would say, if you bring everything to one side, then any value of the variable for which this whole equation becomes 0 is called the root of the quadratic equation. So let us check whether 2 is a solution. What we can do is we just take the value of 2 and substitute it in place of x in everywhere. So we've got x square, so I can write that as 2 square. Then we've got minus 5x, which is minus 5 times 2, plus 6, that is my LHS, and it should be equal to 0, which is my RHS. So 2 square we know is 4, so that becomes 4 minus 5 times 2 becomes 10, plus 6 should be equal to 0, and 4 minus 10 is negative 6. Negative 6 plus 6 becomes 0. So 0 is equal to 0. LHS is equal to RHS. Therefore, we can say that 2 is a solution to the quadratic equation, to the given quadratic equation. What about 3? So this time we are going to substitute the value of 3 to see whether the equation becomes 0 or not. So it becomes 3 square minus 5 times 3, so this is minus not plus, minus 5 times 3 plus 6 should be equal to 0. 3 square gives us 9, minus 5 times 3 gives us minus 15, plus 6 should be equal to 0. So 9 minus 15 is negative 6, and negative 6 plus 6 again gives us 0. So again, because LHS is equal to RHS, 3 is also a solution of the quadratic equation. Right, and the third is how to find the roots by factorization. So that we are going to go into very detail. So basically what we're going to do is we are going to split the quadratic equation into two factors which are equal to P or Q. So let us say that P and Q are two factors of the quadratic equation, and so we know that the RHS should be 0. So we write the quadratic equation as a product of two factors, and since the product is equal to 0, we can safely say that now we'll get 0. There are only three possible conditions. We'll get 0 if either P is equal to 0 or Q is equal to 0 or both of them are equal to 0. Those are the only three possibilities in which we are going to get 0 as the product. Otherwise we cannot get 0. So anything multiplied by anything can be negative, can be positive, unless one of the numbers is 0. So that is why we are going to factorize it into two or more factors, such that if one of the factors becomes 0, then the quadratic equation becomes 0. So how to do that factorization, that also we are going to learn in this video. Right, so let's come to the first question. The first question is we have to identify whether these are quadratic equations or not. So identification, as I told you, is very easy. We just have to look at the powers of x. If it has got positive powers, which means if it has got a power of 1 and 2 and the highest power is 2, then it is a quadratic equation. 1 need not be there, but the power of 2 has to be there, because we know that a should not be equal to 0. So like I told you that a, b and c are the coefficients of x square, x and the constant term respectively, and a cannot be 0, b and c could be 0. So even if b and c are 0, it does not matter, but a cannot be 0. So let us see the first equation here, x square minus 5x plus 3. We see that the highest power of x is 2 here. This has got a power of 1. There are no negative powers, there is nothing, so we can just say that this is a quadratic equation. Second one, if we look, 2x square minus 3 root 2x plus 6 is equal to 0. Now we are looking at only the variables and its power. So the power of x is 2 here, which means the highest power, it does look to be 2, so does look like a quadratic equation, but we'll need to check further. So x, we see 3 root 2 is a real number. So a real number, all rational numbers, all irrational numbers are actually part of real numbers. So 3 root 2 is a real number. X is not within the square root. You can clearly see that it is written outside the square root, which means x has a power of 1. So again, this also turns out to be a quadratic equation. Third one, 3x square minus 2 root x plus 8 is equal to 0. Again we see that x highest power is 2, but that is not enough to say whether it's a quadratic equation or not, because here we see that root x, whenever root x comes, that means x has a power of 1 by 2, and 1 by 2 is not a positive integer. Therefore we can safely say that this is not a quadratic equation. Fourth one, 2x square minus 3. So like I told you, there are three things, a, b and c, in which the condition is that a should not be equal to 0, b and c could be equal to 0. So here something is missing, which means that we can say that b is equal to 0, because of which say 2x square minus 0x minus 3 is equal to 0. So this can be written like this. Now this term is missing from this equation, and that is only because it is being multiplied by 0, and 0 multiplied by 0 is 0 multiplied by anything is 0, so we don't need to write that because 0 has no value. So B can be equal to 0, C can be equal to 0, but A cannot be equal to 0. And here A is not equal to 0. It has got a power of, it has got a coefficient. A is equal to 2. X has got the highest power of 2. So no other powers of X. So this also is a quadratic equation. Part E. Now surely x plus 1 upon x, this does not look to be a quadratic equation, because we can see that x, it can also be written as x to the power 1 plus x to the power minus 1 is equal to 2. And because minus 1 is not a positive integer, therefore it cannot be a quadratic equation. But in such cases, it is always prudent, or it is always advisable to simplify the equation if possible, and then see if it is a quadratic equation or not. So when we simplify it, what we can do is we can take this equation x plus 1 upon x is equal to 2 and multiply both sides of the equation by x, because x is the denominator. So when we do that, we get x times x, which is x square, plus 1 times 1 upon x times x, which is 1, is equal to 2 times x, which is 2x. Now bringing everything to the same side, we get x square minus 2x plus 1 is equal to 0. And now if we compare it, we can write it in the form ax square plus bx plus c is equal to 0, and therefore it can be said that this is a quadratic equation also. Once we have simplified it, we find that it is a quadratic equation. Now there is also a video that I've made on a similar thing, identification of quadratic equations and factorization of quadratic equations, which is linked in the description box below. So make sure you check out that link, and you are able to, so that you better understand how to factorize it. Now let's look at the next equation also, which is x plus 1 upon x is equal to x square. Now this also looks to be a quadratic equation, but again we'll have to simplify it, because here we can see it can be written as x plus x to the power negative 1, which is equal to x square, and because the negative power is there, therefore it cannot be a quadratic equation, so we need to simplify it further. So again I'll take the quadratic equation x plus 1 upon x is equal to x square, and multiply both sides of the equation by x, and this also by x. So I get x times x is x square, plus 1 upon x into x gives us plus 1, is equal to x square times x gives us x cube. Bringing everything to the same side, we get x cube minus x square minus 1 is equal to 0. Now we see that the highest power of x in this case has become 3, which means it's a cubic equation. It's no longer a quadratic equation. So even after simplifying, we are not getting a quadratic equation, so we can say that this is not a quadratic equation. Let's look at the last one also. So again, uh, to look at the last one, we need to again four x square into 1 upon x square gives me 4 is equal to 17 upon 4 into 4x square gives me 17x square. Bringing everything to the same side, we get 4x to the power 4 minus 17x square plus 4 is equal to 0. Now again we see that the highest power of x in this case is 4, which again makes it pretty clear that this also is not a quadratic equation. So this is how you identify whether a quadratic equation it is, whether an equation given is a quadratic equation or not. So lots of questions can come related to this. Mostly I think it will be multiple choice questions because these are pretty easy to identify. So that's how you can do it. But sometimes the equation here I've given straightforward simple equations, but sometimes they are not so simple, they become a little complicated, in which some simplification is required. So you might get 2 markers questions there that simplify this equation and then tell whether it's a quadratic equation or not. So let us have a look at those type of questions also. So I've got 4 of them and we need to identify whether these are quadratic equations or not. Now, remember the the next one you should get an idea. So 2x, so we take the first term 2x and multiply it by the complete second term in the bracket, so that's x minus 3. Then you take this part of it including the sign, which is -1, and multiply it by the complete bracket on the other side, or on the other bracket, the other product that is there. So x minus 3, that should be equal to 0. Again we'll follow the same steps. Take x, multiply it by x minus 2, take this sign with the sign, so plus 4 multiplied by x minus 2, and then you just distribute, and after distribution whatever you get, you bring everything to one side and compare it with the form ax square plus bx plus c is equal to 0. If it can be written in that form, then it is a quadratic equation, otherwise not. So can you quickly do the question and tell me whether this is a quadratic equation or not? I'm waiting for you in the comment section, and please leave a comment in this chat and tell me whether, what do you think, part A, B, C and D, which ones are quadratic equations and which ones are not. Right, so let's have a look while you people are solving. I'll also solve it here, and let's see what 2x times x becomes 2x square, 2x times -3 becomes -6x, negative times -1 times x gives us -x, -1 times -3 gives us +3. That should be equal to the other side. X times x is x square, x times -2 gives me 2x, -2x, plus 4 times x gives us positive 4x, and 4 times -2 gives me -8. Simplifying, I'll first simplify the left hand side, then simplify the right hand side, and then bring everything to one side. So that just makes it little easier. So this becomes 2x square, -6x minus x gives us -7x plus 3 is equal to x square plus 2x minus 8, and when I bring the x square to the other side, I get 2x square minus x square, which is only x square. I take 2x to the other side, which becomes negative, so -7x minus 2x becomes minus 9x, and I bring 8 to the other side, so 3, so 8 becomes positive after going to that side, so 3 plus 8 gives me 11, so plus 11 is equal to 0. And here we see that the highest power of x is 2, and there are no negative powers of x, no rational powers of x, they are all integers, positive integers with the highest power of 2. So this is a quadratic equation, right? So you can get a 2 marker here. I'm still waiting for the comments. No, you people are not participating in the stream, which is very important that you do send in your answers before I solve it. What do you think of the second one? Is this a quadratic equation or not? Well, to look at it by eyeballing it. What do you mean by eyeballing? Eyeballing means when you look at the question or the situation or the problem, Eyeballing means you're just looking at it and trying to make a guess whether it will be a quadratic equation or not. So eyeballing it, I can see that x plus 2 is to the power cube. So if it is to the power cube, I will get x cube, and in that case the highest power of x will become 3, in which case it is not a quadratic, it will not be a quadratic equation. But again, eyeballing it is just a guess. It does not give you an accurate answer. Accurate answer you can only get after simplifying it. So let me simplify it and let's see what we get. So you remember the formula that a plus b whole cube. This is an identity also, that it is a cube plus b cube plus 3a square b plus 3ab square. So that is the identity that we are going to use here, and using that identity, x plus 2 would then become x cube plus 2 cube, which is 8, plus 3 times x square, so times 2, which is plus 6x square, and plus 3 times 2 square. 2 square is 4, 4 times 3 is 12, so that becomes plus 12x. That should be equal to, I'll distribute on the other side, so 2x times x square becomes 2x cube, then 2x times negative 1 gives me negative 2x. Now what do we see? We take everything to the right hand side. So on the left hand side I will or bringing everything to the right hand side, so I get 2x cube minus x cube, which gives me only x cube. Then I take 6x square to the right hand side, that becomes negative 6x square. Then I take 12x to the other side, so that also becomes negative, and added to negative 2x it becomes negative 14x, and 8 also goes to the other side, becomes negative, so minus 8 is equal to 0. Now comparing this to ax square plus bx plus c is equal to 0, it is not in that form because the highest power of x is 3. So this is also not a quadratic equation. Right, let us look at the third one. So again, looking at eyeballing, it's not going to be a quadratic equation, but eyeballing is only an estimate. So let's check whether it is a quadratic equation or not. Let me simplify using the same identity, a plus b whole cube. So we get x cube plus 1 plus 3x square plus 3x. That should be equal to x cube plus x plus 6. Now bringing everything to the left hand side, I get x cube minus x cube, so that becomes 0. I don't need to write it. 3x square, there is no x square term there, so I can write 3x square. I bring x to the left hand side, so 3x minus x will give me plus 2x, and I bring 6 to the other side, so that becomes negative. 1 minus 6 gives me minus 5 is equal to 0. So I see when I simplify it, the x cube gets cancelled, and what we are left with, comparing it to the form ax square plus bx plus c, yes indeed it is in that form, even though c is negative, so it can be negative, I told you. So this is a quadratic equation because the highest power of the variable is 2. There are no negative powers of x here, no rational powers of x here, so it is indeed a quadratic equation. Let's look at part D also. Are you people also doing it along with me, or am I the only one doing it? Let's look at part D and see what answer do we get. So simplifying it, this I think on the left hand side is only distribution, so x times x gives me x square, and 3 times x gives me plus 3x plus 6. On the right hand side, x plus 2 times x minus 2, so a plus b into a minus b gives me a square minus b square, which in this case will become x square minus 4. Bringing everything to the right hand side, we get or bringing everything to the left hand side, so x square, this x square when it goes there, it will become x square minus x square, that becomes 0, so we don't need to write it. 3x is already there, there is nothing, no x term on the right hand side, and minus 4 goes to the other side, becomes positive, added to 6 becomes plus 10 is equal to 0. Now we see that this is not a quadratic equation because a has become equal to 0, and when a becomes 0 the power of 2 disappears, the power of 2 of x, it disappears, it is no longer there. So the highest power of 2 is only of the variable is only 1, in which case it becomes a linear equation, it is no longer a quadratic equation. So this is not a quadratic equation. Now let's come to factorization of quadratic equation, or let's come to how to check whether the any equation, whether there are the numbers given are roots or solutions of the quadratic equation or not. So as I told you in the beginning, it is very easy to check that. We'll just substitute these values in the equation and see whether it is equal to that or not, whether it is equal to 0 or not. So if LHS is equal to RHS, then it is a root or a solution of the equation. If LHS is not equal to RHS, then it is not a solution. So let's check for root 2 first. So part A, I take the value of x as root 2, putting it in the equation, I get x square, so which means root 2 square plus root 2 times x, x again is root 2, so root 2 times root 2, negative 4 minus 4 should be equal to 0. So let me remove the is equal to 0. Let me look only at the LHS right now. So root 2 whole square gives me 2, and plus root 2 times root 2 gives me 2, and minus 4. So I get 2 plus 2 is 4, 4 minus 4 is equal to 0. So LHS is equal to 0 and RHS is also equal to 0. So we can say that LHS is equal to RHS. Therefore, root 2 is a solution. Root 2 is a solution or is a root of the quadratic equation. Let us look at part B, which is 2 root 2. So here we are putting the value of x as 2 root 2. So we have got x square, which means 2 root 2 whole square, plus root 2 times x, so root 2 times 2 root 2, because x is equal to 2 root 2, minus 4, so that is my LHS, and so 2 root 2 square, so root 2 square gives us 2, 2 square gives us 4, 4 times 2 gives me 8, so this becomes 8, plus root 2 times root 2 gives me 2, 2 times 2 gives me 4, so this becomes plus 4 minus 4, so 8 plus 4 is 12, 12 minus 4 is 8, so LHS is equal to 8 and RHS is equal to 0. So which means LHS is not equal to RHS, therefore 2 root 2 is not a solution. So that's how you check whether it's a solution or not. Very easy. I've taken only one such question so that you understand that if you get a 2-mark question in the exam, you are able to solve it. Now, as I said, I'm not only here to solve my own questions. You people also, if you give your question something in which you find it difficult, you can please share it in the chat box and I'll be most happy to explain it to you. Right, let's look at part C, which is we'll take the value of x is equal to negative 2 root 2 this time, and let's see whether that is a solution of the quadratic equation or not. So again we look at the LHS. Now instead of x we are putting in the value of negative 2 root 2. So x square becomes negative 2 root 2 whole square plus root 2 times negative 2 root 2, negative 4. So that is my left hand side. Negative square becomes positive. 2 root 2 square, as we just saw, was 8. Then here again root 2 times root 2 is 2, 2 times 2 is 4, and we have got a negative sign, so that becomes minus 4, and then we have got this minus 4 at the end. So my left hand side becomes 8 minus 4, which is 4, and 4 minus 4 is equal to 0. LHS is equal to 0. RHS is also equal to 0, which means LHS is equal to RHS, and whenever LHS is equal to RHS, then that means that here negative 2 root 2 is a solution of the quadratic equation given. That's how simple it is, and I don't think it is very difficult for you people to understand. So now let's come to the crux of today's live stream, which is factorization. Now 35 minutes of the stream is already up. We have already spent a lot of time on identifying quadratic equations, but from here on we'll try to pick up a little bit of speed, because once we understand the process how factorization needs to be done. So in the first two questions I'm going to spend a little bit of time, but once you've got the idea how to do it, then we can just rush it up a little bit. So again, we have to factorize it like I told you. We have to write it in terms of two factors, let's say p and q, and that should be equal to 0. So if the product of two numbers is equal to 0, there are only three possibilities, that either p is equal to 0 or q is equal to 0, or both p and q are equal to 0. So that is what we are trying to do here. We are trying to resolve the quadratic equation into two or more factors, such that if one of the factors becomes 0, then we can find the solution of the quadratic equation. That's what we are aiming to achieve by using the factorization method. So let us write this equation first. 4 root 3 x square plus 5x minus 2 root 3 is equal to 0. Let's compare it to the general form of the equation, which is ax square plus bx plus c is equal to 0. Now comparing these two equations, we can easily say that a should take a value of 4 root 3, b should take a value of 5, and c should take a value of negative 2 root 3. So make sure that you take the sign also along with it. Don't take only the coefficient or the numeral part of it, take the sign before that also as a part of it. Now a is not equal to 0, so this is a quadratic equation for sure, because the highest power of x is 2. So the way to factorize it, the first step is to find the product of a and c. A multiplied by c, in our case we'll ignore the sign in this case in the product, so that becomes 4 root 3 times 2 root 3. And when we do that, so root 3 times root 3 becomes 3, 4 times 2 becomes 8, 8 times 3 becomes 24. Now the product of a and c is 24. The second step is to find factor pairs of 24, such that we need to find a product of two factors which gives us this number 24. So let us look at all the possible options. So one option is that 24 times 1 is equal to 24. The second option is that 12 times 2 is equal to 24. The third option is that it could be 8 times 3, which is equal to 24, and the fourth option, which is 6 times 4 is equal to 24. And then there are other options also, that 4 times 6 becomes 24, or 3 times 8 becomes 24, but that is just the same as the options that are already written, because we know that multiplication is commutative. So we don't need to go into those things again. So just look at this. Then the second step, what we do is, let me write the quadratic equation again. 4 root 3 x square plus 5x minus 2 root 3 is equal to 0. Now make sure what you do here, what I am doing here, I look at this sign. This sign is negative. When this sign is negative, negative means difference. So we are going to find the difference of these factor pairs. So 24 minus 1 gives me 23. 12 minus 10, 12 minus 2 gives me 10. 8 minus 3 gives me 5. 6 minus 4 gives me 2. Second thing, whenever we see a negative sign here, that means one of these factors has to be positive and the second one has to be negative. If the sign is positive, then that means both the factors have to be positive or both have to be negative. But when we have a negative sign, we look at the factor pair. So we say that one has to be positive, one has to be negative, and then the second thing that we do is we look at this coefficient of x. This coefficient of x is equal to 5, and we look for that factor pair which is equal to 5. So we've got 5 here, which means the factor pair is 8 into 3. So this is also called the middle term splitting method, which I have again explained in detail in a video which has been mentioned in the description box. So do make sure that after the live stream you watch that video and see how it is done. It is a short 8 minutes video, I think. I think it's only 8 minutes or maybe lesser. So it's not going to take too much time, and that you understand in great detail how to factorize the quadratic equation. So we look at this. So 5, now we have to split this 5 into 8 and 3 such that the third thing that we do is we look at this sign. So it has to be positive 5. So to make it positive, the larger number is going to take this sign. This negative sign here tells me that one has to be positive, one has to be negative. So this positive sign here tells me that the larger number has to be positive, which means 8 will be positive and 3 will be negative. And then I split this 5x into two terms which include 8x and 3x. And 8x has to be positive, 3x has to be negative. So let me write the quadratic equation again by splitting the middle term. So I get 4 root 3 x square plus 5x is now I'm going to split it. So it's 8x and negative 3x. I prefer to take the negative term first, so it makes things a lot easier. So negative 3x plus 8x. Now this together becomes plus 5x, and then we have got minus 2 root 3 at the end is equal to 0. Now let's see what we are going to do is we are going to factorize the first two terms and factorize the next two terms. So anything that's common in the first two terms, we take it outside the brackets and write the remaining inside the brackets, and same we are going to do with the second two terms also. So in the first one we see that 4 root 3 and 3, nothing is common, but I think I can take root 3 as common. So I'm getting an idea of root 3 because I see that root 3 is figuring both in the first term in A as well as C. Sorry, please let me not distract you, but I hope you don't mind if I have a cup of coffee too. Thank you. Cheers. Right. So basically what we are going to do is we are going to we are going to take root 3 as a factor, as a we factorize that out. We can also see that x square is there in the first term and x is there in the second term, so I can factorize out x also. Then what am I left with inside the bracket? So I see that root 3 has come out, x has come out, and inside the bracket I am left with 4x. And in the other term I get minus, x has come out, root 3 has come out, so the only thing that is left is negative root 3. So 4x minus root 3. In the second two terms, what do I see is common? 8 and 2. I think 2 is common in that. X is not common, root 3 is not common. So this again leaves me inside the brackets. 4x minus 2 has come out, so minus root 3. That should be equal to 0. Right? So pretty easy so far. Right, and then we have got this thing. We just see that 4x minus root 3 is common in both these terms, so I can just factorize that out. So I can write 4x minus root 3 as common in both the terms. What am I left with in the first term? It's root 3 times x, and in the second term I'm left with only plus 2, so that is equal to 0. Now you see you have the quadratic equation as a product of two factors, and the product is equal to 0. So if the product is equal to 0, that means either this is equal to 0 or this is equal to 0, or both are equal to 0. So I can say that 4x minus root 3 is equal to 0, or root 3x plus 2 is equal to 0. Now a quadratic equation has at the most two solutions. It can have one also, it can have no solutions also, but at the most it can have two solutions. It can't have three solutions. Right, so the two solutions, I think there are going to be two solutions in this. So to find the value of x, we take root 3 to the other side, that becomes positive root 3, and then we divide by 4 because it was 4x was equal to root 3. So dividing by 4, this 4 comes here. So x takes a value of root 3 upon 4. So that is a solution of the equation. In the second one, we take it was root 3x. I take 2 to the other side, so it becomes negative 2, and again dividing by root 3, it comes here. So the second solution of the quadratic equation is negative 2 upon root 3. So these are the two solutions of the quadratic equation. Right, and right, let's move to the next question also. And next question we see is we are going to solve it by factorization again. Here it looks a little bit complicated because we have got again seems to be a variable a, b, so these look to be variables, so becomes a little bit complicated, but if you think about it, it's not very complicated. I'll just explain it to you in a very simple way how to do it. So let me write the quadratic equation again. 4x square minus 4ax plus a square minus b square is equal to 0. Now the first step what did we do was to find the product of a and c. So a in this case is 4 and b is a square minus b square. So the product of that is obviously 4a square minus 4b square. Now we have to find factors of it. So factors of it, 4a square minus 4b square, it is in the form x square minus y square or m square minus n square or a square minus b square, which can be factorized into what can you say, a plus b into a minus b. So this also I can write it as 2a minus 2b times 2a plus 2b, right? We can do that, no problems. Yes. So then we look at this sign over here. This sign is positive. So positive means we are going to add the two factors. So this is I can also have other combinations also. So I can also have it as 4 into a minus b into a plus b. That is one other solution that we have. Then we have what else can I take? I think these are the only two possible solutions. Yes, these are the only two factor pairs possible. Now this positive sign indicates that we have to add the two factors. So when we add the two factors here, we get 4 plus a minus b plus a plus b. The b gets cancelled and we get 4 plus 2a. So that is obviously not that we are looking for, because we were looking for 4a, not 4 plus 2a. We look at these two factor pairs. So we get 2a minus 2b plus 2a plus 2b. So again 2b and 2b gets cancelled and we are left with 4a, and that's what we wanted. This is the factor pair that we are going to choose. And then we look at this sign. This sign is positive, which means that both have to be either positive or both have to be negative. This sign here is negative. That means that both of these should be negative. So I am going to take both these factor pairs as negative. So let me do the middle term splitting now. So I get 4x square minus 4ax. I am going to write it as minus 2a minus 2b times x minus, because both have to be negative, so minus 2a plus 2b times x, and a square minus b square, I'll again factorize it as 2a minus 2b times 2a plus 2b. That should be equal to 0. Now let's look at what is common in the first two terms. In the first two terms, maybe I can factorize out the 2. So I can bring that out. So 4 and 2, I think I've got 2 common there. we've got x square in the first term, x in the second term, so x also is common. What we are left with inside the brackets is 4x square divided by 2x gives me 2x. Then minus, I've taken out the 2 already, so minus, we are left with a minus b, and I close this. Then in the second two terms, what is common, and I see that 2a plus 2b is common, and I'll take the negative sign also as common. So when I take the negative sign common, remember that everything within the brackets changes its sign. So I take the negative sign common, and I know that 2a plus 2b is common in both the terms. And what are we left with? So inside the bracket we are left with x. Sorry, what I can do is I can let the 2 remain inside. So I'll take a plus b is common, and I'll take 2x here, 2x, and again we are left with what? Again 2 I've taken outside, so no, 2 remains inside, so that becomes minus a minus b. Right, that should be equal to 0. And when we simplify this further, what do we get? So we have converted into two products. Now we see that 2x minus a minus b, that is common in both the terms. So I write it as 2x minus a minus b. What are we left with within the first brackets? It's 2x. What are we left with in the second bracket? It's minus a plus b. So a plus b is common, and yeah, that should be equal to 0. And if that is equal to 0, then we can say that 2x should be equal to right, 2x minus a minus b should be equal to 0, or we can say since the product of two factors is equal to 0, then one of or both the factors should be equal to 0, which means 2x minus a plus b should be equal to 0. Now therefore, finding the value of x, we take a minus b to the other side, it becomes positive, so it's a minus b upon 2 we divided by 2, or in the second case we take a plus b to the second side, it becomes positive, so 2x is equal to a plus b, therefore x is equal to a plus b upon 2. So the two factors are a minus b upon 2 and a plus b upon 2. Simple, isn't it? Let's move to the next question straight away without wasting any further time. Let's do it a little more quickly now that we have got the hang of it. So first two questions I told you I'll go a little slow, and now we are going to pick up speed. So again, let me write the equation first. 9x square minus 6b square x minus a to the power 4 minus b to the power 4. So I know that I look at 9 and I look at this, so I can write it, the product is 9 into a to the power 4 minus b to the power 4. I need to write it as factor pairs, so I can, one factor pair is this itself, but I can factorize out a to the power 4 minus b to the power 4. So I can say 9 into a square minus b square times a square plus b square. That is one factor pair that I've got. Or I can take it as 3 into a square minus b square times 3 into a square plus b square. That is another possibility that I've got. What else? I think these are the only two possibilities. Then we look at this sign, so we have to subtract. So in the first case we get 9 minus this, even if it cancels out, it's going to give me 9 minus something, which is not what we are looking for. Let's look at the second one. So second one, if I distribute it, so I get 3a square minus 3b square, and I'm going to subtract from that 3a square minus 3b square, sorry, plus 3b square. And when I distribute this negative sign, I get 3a square minus 3b square minus 3a square minus 3b square. So we get sorry, not this, I've cancelled the wrong one out, but this and this gets cancelled, 3a square and negative 3a square. So we are left with negative 6b square, and that's what we were looking for. And because subtracting this one from this one gives us the answer, so therefore we are going to split into these two middle terms. So which one are we taking as positive? So this is positive and this is negative. So because this negative sign says that one of them has to be positive, one has to be negative. So we have got which one is positive, which one is negative. Let's simplify. So rewrite the equation. We get 9x square. I'm going to take the negative factor first, so minus 3, let me factorize it out, minus 3 times a square plus b square times x, because x is also there at the end. And now I'm going to write the positive factor, so 3 times a square minus b square minus a to the power 4 minus b to the power 4. Again I'll split it into factors, a square minus b square times a square plus b square, and that should be equal to 0. Looking at the first two terms, what is common? I can clearly see that 3 is common. I can clearly see that one of the x's is common. What I'm left with inside the bracket will be 3x, minus 3 has come out, so it's only a square plus b square. And in the second two terms, I see that obviously a square minus b square is common. Taking that as common, inside the bracket, sorry, there was an x here also. Inside the bracket I get 3x, and here I'm going to take, so I've taken a positive outside, so this negative sign will come, and we are left with a square plus b square. That should be equal to 0. Now again, if we have written it as a product of two factors, and if a product of two factors is equal to 0, that means either one of the factors is equal to 0. Sorry, we are not done yet, so we have to we know that this thing is common in both of them, so we'll write that 3x minus a square plus b square is common. Within the other brackets I get 3x plus a square minus b square. That's the other one. That should be equal to 0. Now we have written it as a factor of two products, which means that 3x minus a square plus b square is equal to 0, or 3x plus a square minus b square is equal to 0. So when I do this, when I take a square minus b square, negative a square minus b plus b square to the other side, I get 3x will be equal to a square plus b square, or dividing by 3 I can say x will take a value of a square plus b square upon 3, or in the second case I take positive a square minus b square to the other side, it becomes negative, so I can change the places of the variables, so it can become b square minus a square, and then dividing by 3 we can get this. So x can take a value of a square plus b square upon 3, or b square minus a square upon 3. In both the cases the LHS will be equal to RHS. Let's look at the next question. Looks a little bit complicated again, but nothing complicated. Like I tell you, it's going to be very simple. We just have to simplify the equation a little before we try to find the factors. So right, whenever we have fractions, we know that we need to simplify it by finding the LCM. LCM in this case, because we don't know the value of x, I think LCM is just going to be the product of the two numbers, so x plus 4 times x minus 7. Now because we have got x plus 4 in the denominator of the first term, so we are going to multiply the numerator by the second term, which is 1 times x minus 7, which is only x minus 7, and then we have got a negative sign, so I'm going to multiply, since the denominator of this term is x minus 7, we are going to multiply the numerator by the other term, which is x plus 4, which is only x plus 4. That should be equal to 11 upon 30. When I simplify it, I get x minus 7 minus x minus 4 upon, in the denominator I'll distribute it, so a plus b into x plus a into x plus b, we are going to apply that property here. So when we apply that property, what we can do is we get x square plus a plus b times x. So plus 4 minus 7 gives me minus 3x times ab. So plus 4 into minus 7 gives me minus 28. Minus 28 should be equal to 11 upon 30. When we simplify this, x and negative x gets cancelled out. We are left with minus 11 upon x square minus 3x minus 28 is equal to 11 upon 30. Since 11 is in the numerator on both the sides, I can cancel out the 11 and we are just left with 1 over this. So now we can just cross multiply. So I'll take, when I take this to the other side, multiply by 1, I get x square minus 3x minus 28 is equal to minus 1 into 30 gives me minus 30. Now bringing minus 30 to the other side, I get x square minus 3x plus 2 is equal to 0. Right. So now we need to factorize it. To factorize it, we take the product of a and c, which is equal to 2. Only one factor pair possible, which is 2 times 1. We look at this sign, which is positive. We add the 2. We get 3. That is what we were looking for. But we look at this sign, which is negative, and this sign, which is positive, which means both have to be negative. So we'll take negative 2 and negative 1. Since both are negative, it doesn't matter whether you write the negative one first or the positive one first. You have to write both negative. So it becomes x square minus 2x minus x plus 2 is equal to 0. In the first two terms, x is common, we get x minus 2. In the second two terms, I take only minus common, but can't take minus only common. I can write minus 1, and within the brackets I'll then be left with x minus 2, which is equal to 0. X minus 2 is common in both the terms, so x minus 2 times what are we left with, x minus 1 is equal to 0. So which means x minus 2 is equal to 0, or x minus 1 is equal to 0, which means x is equal to 2 or x is equal to 1. So we have factorized it and we have found the solution of this quadratic equation. Right, let's move to the next question. Next question is again looks complex, looks complicated, and this I think is not complicated, but I think it may be a little bit lengthy. Let's see but how to do it. So we can say that 1 upon a plus b plus x. So we need to simplify it first and then we'll see what values do we get. So 1 upon a plus b plus x. On the right hand side, I can only take the LCM of a, b and x has to be abx. In the numerator, a is the denominator, so I multiply by the other two factors, which is bx. In the second one, b is the denominator, so I multiply by ax. Then in the third one, x is the denominator, so I multiply by ab. And then I just cross multiply. So when I cross multiply, I get a plus b plus x times bx plus ax plus ab. And right, what else? On the right hand side we get 1 times abx, which is abx. Excuse me. Now we'll have to just simplify the left hand side, which looks a little complex, but anyways we'll do it. So it becomes a times bx plus ax plus ab plus b times bx plus ax plus ab plus x times bx plus ax plus ab. That should be equal to abx. When we distribute it, we get abx plus a square x plus a square b plus b square x plus abx plus ab square plus bx square plus ax square plus abx is equal to abx. So obviously one of the abx we can cancel out on both the sides, so the right hand side now becomes 0. On the left hand side, what do we get? So let me write the x square terms first, that makes sense. So let me rewrite this as a square x, sorry, not a square x but ax square, yeah, ax square plus bx square, or I can even factorize out the x square so that it becomes a little easier. So not to miss the steps, but I can write it as a square plus b square. Again making a mistake, it's not a square plus b square, it's a plus b, because a and b do not have powers here. So a plus b times x square. Then I'll write the x terms. So x terms, where what all do we have? We have abx, we've got a square x, we've got b square x, we've got abx. That's it. Yeah, that's it. So we've got 2 abx, so I can write it as a square plus b square plus 2ab, and all of that in x is common, so I can write x plus, we are looking at the constants now, so ab square plus a square b, so I can take probably ab as common and I can write it as a plus b. That should be equal to 0. Now we have done the major part of it. Solving part is over. Now let's look at the factors. So I know that this a square plus b square plus 2ab looks a little bit familiar. So I can write it as a plus b times x square plus a plus b whole square times x plus ab times a plus b, which is equal to 0. Now what do we need to look at the product of the two factors. So this product of a and c. So when we do that, what do we get? We right, so we take the product of this, so a plus b into a plus b into ab. We are going to look at this sign. This sign is positive, which means we have to add it. Let's add it and see what do we get. So when we add it, we get a plus b plus a plus b plus ab, which is 2a plus 2b plus ab. Doesn't make sense, isn't it? Okay, but what can we look here? If we look here closely, we can see that a plus b is common in all of them. So we can probably take out a plus b as it is, and then we are left with x square plus a plus b x plus ab is equal to 0. Now that's what we were looking for. So a plus b, now since it is a product of two factors, we can say that a plus b is equal to 0, or we can divide by a plus b. We are only left with x square plus a plus b times x plus ab is equal to 0. Now it becomes easier. So we are looking at the product of a and c, which is only ab. We are looking at this sign, which is positive, so a plus b, and that was what we were looking for, a plus b, right? And because this sign is positive, both has to be positive, because this is also positive. So we can write it as x square plus ax plus bx plus ab is equal to 0. We'll factorize out x from the first term, we are left with x plus a. We'll factorize out b from the second term, we are left with x plus b, sorry, x plus a again is equal to 0. Now x plus a is common in both of them, and we are left with x plus b. That should be equal to 0, which means if x plus a is equal to 0, then x is equal to negative a, or if x plus b is equal to 0, then x is equal to negative b. So we have factorized this also when we have found the solution of this. Now we have got a comment from one of our there's a coaching classes from USA. Good evening, Trump coaching classes, and glad to see you here, that you're looking at the stream, and it's nice to see you here. Let's go to the next question that we have. So again, looks a little bit complicated, but now because we know how to solve these questions, we are going to find the LCM, which is x minus 3 times x minus 5. X minus 3 is the denominator, so we multiply x minus 2 by x minus 5. Then we have got a positive sign, multiply x minus 4 by x minus 3. That should be equal to, write it as an improper fraction, 10 upon 3. I'll simplify again using the property x plus a times x plus b. So pay attention. So it's going to be x square minus 7x plus 10 plus x square minus 7x plus 12, okay, over x square minus 8x plus 15 is equal to 10 over 3. When I simplify this, I get 2x square minus 14x plus 22 over x square minus 8x plus 15 is equal to 10 over 3. I cross multiply now, so I multiply this whole thing by 10, and I get 10x square minus 80x plus 150 is equal to, multiply this whole thing by 3 is equal to 6x square minus 42x plus 66 is equal to 0. No, not is equal to 0. That's it. Right. Take everything to the left hand side. So 6x square, when it goes there, it becomes negative. So we are left with 4x square minus 42x goes there, it becomes positive. So we are left with negative 38x, and 66 goes that side, becomes negative, and we are left with how much? 150. So 34 and 50, 84 plus 84, that should be equal to 0. I can see that 2 is common in all of them, so I can write it as 2x square minus 19x plus 42 should be equal to 0. Dividing by 2, so 2 I can just remove. So now we are looking at the product of 2 and 42. So let me write it here. 2 into 42 is equal to 84. We are looking at the factor pairs of 84. So that's 84 into 1. That's 42 into 2. That's divisible by 3 also. So 28 times 3. That's divisible by 4 also. So 21 times 4. That's divisible by 6 also. So 14 times 6. That's divisible by 7 also. So 12 by 12 times 7. That's not divisible by 8. That's not divisible by 10. 9 by 10, no. By 11, no. By 12, yes. But 12 we have already got. So these are all the factor pairs that are possible. Then we look at this sign, which is positive. So we find the sums. So we have got 85, we have got 44, we have got 31, we have got 25, we have got 20, and we have got 19. We look at this term 19. This is what we are going to choose. We look at positive sign here. So positive means both have to be positive or both have to be negative. We look at this sign, it is negative, so both have to be negative. So I write it as 2x square minus 12x minus 7x plus 42 is equal to 0. I take 2x as common in the first term. I am left with x minus 6. In the second one, I take negative 7 as common. I am left with x minus 6 is equal to 0, which means that either x minus 6 is equal to 0, or we can say that 2x minus 7 is equal to 0, which means x will be equal to 6, or in this case x will be equal to taking 7 to the other side and then dividing by 2, so it will be x will be equal to 7 upon 2. So going very quickly now, and let's move to the next question. Again, I've taken some complicated questions because these are all 4 markers that may come in your exams, and it is important to do these, otherwise you will get stuck in the exam. So I hope you understand that why it is important to know how to do these questions, otherwise you might just end up losing 4 marks or 8 marks altogether, which is not good. So you need to get full marks in the board exams, right? Right, so be with me and we are going to do that. So again, I'll left hand side, I'll simplify, take the product of x plus 3 and 2x minus 1. On the top I get 2x minus 1 plus x plus 3, which should be equal to 11 upon 7x plus 9. I simplify, I get 3x plus 2 in the numerator. In the denominator I can just multiply, so I get 2x square, then I get 6x minus x, which is plus 5x minus 3. On the right side I get 11 upon 7x plus 9. I can cross multiply, so I get 3x plus 2 times 7x plus 9 should be equal to 11 times this, so that becomes 22x square plus 55x minus 33. I can simplify this left hand side, so 3x into 7x is 21x, 3x into 9 is 27x, 2 into 7x is 14x, 27 plus 14 is 41x, so 21x square plus 41x, and 2 times 9 is 18, so plus 18 should be equal to 22x square plus 55x minus 33. Now taking everything to the right hand side, 22x square minus 21x square becomes only x square, 55x plus, or that becomes minus 41x, so that becomes plus 14x, and 33 minus 18 becomes minus 51 is equal to 0. Now that's a quadratic which we can easily factorize. So we are looking at the factors of 1 and 51, which is equal to 51. Only 2 factor pairs possible, I think, which is 51 into 1 and 17 into 3. No other factor pairs. We are looking at this sign, so we have to subtract. 51 minus 1 is 50, 17 minus 3 is 14. We look at this 14, so this is what we are going to choose. This negative sign means one of them is going to be positive, one of them is going to be negative. We look at this sign, which is positive, so the bigger number has to be positive, the smaller number has to be negative. Once we have done that, we do the middle term splitting, taking the negative number first, so negative 3x plus 17x minus 51 is equal to 0. Taking x as common, I'm left with x minus 3. In the second case, I take 17 as common, I'm left with x minus 3, which is equal to 0. X minus 3 is common in both of them, and x plus 17 is common, is left out. So that means x minus 3 is equal to 0, which means x should be equal to 3, or x plus 17 is equal to 0, which means x should be equal to negative 17. I hope you are getting a gist of what we are doing, and let's move very quickly. Let me see how many questions are we left with. No. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 8 questions. We need to pick up a little bit of speed because I think 1 hour and 18 minutes of the stream is already over. So anyways, let's do it. So this 5 to the power x plus 1 plus 5 to the power 2 minus x is equal to 5 cube plus 1. Let's simplify. So I can also write this as 5 to the power x multiplied by 5, because the law of exponents, you remember, when the multiplication with the same bases are there, the exponents get added. So the reverse is also true. So whenever we see a product, the exponent as a addition of two things, we can multiply it. When it is a subtraction, we can divide it. So it becomes 5 square divided by 5, 2 minus x, divided by 5 to the power x is equal to 5 to the power 3 is 125 plus 1. Now I can just say we've got 5 to the power x here, 5 to the power x here. So I can say let 5 to the power x be equal to y. That will just simplify things. So using that we get 5y because that is being multiplied by 5. So 5y plus y is in the denominator. So we get 5 square is 25. 25 upon y is equal to 126. Now I can multiply this whole thing by y. So when we do that, we get 5y square plus 25 is equal to 126y. Bringing everything to the left hand side, we get 5y square minus 126y plus 25 is equal to 0. We look at the a and c, which is 5 into 25, which is 125. I think it is pretty clear looking at it that there's only thing possible as 125 into 1, which positive sign. So that means when we add it, we get 126, which is what we want. This positive sign here means both have to be positive or both have to be negative. This negative sign here means both have to be negative. So I can write it as 5y square minus 125y minus y plus 25 is equal to 0. I can take 5y as common and I'm left with 5y minus 25, and I take minus 1 as common and I'm left with y minus 5 is equal to 0, which means y could be equal to 5 because y minus 5 is equal to 0, or we can say 5y minus 1 is equal to 0, which means y will be equal to 1 by 5. So two values of y, either 1 or 5. Either 5 or 1 upon 5. But the question is not complete yet because we saw we had to find the value of x, not y, and we had substituted y to be equal to 5 to the power x. So we can say 5 to the power x is equal to 5 to the power 1, or 5 to the power x is equal to 5 to the power minus 1. Now because the bases are the same, the exponents also should be the same, which means x should be equal to 1 or x should be equal to negative 1. Simple, right? Not very difficult. Let's move to the next question that we have. So again, this is, I think, pretty straightforward. We are just going to find the product of this and this. So 4 root 6 into 2 root 6. Root 6 into root 6 gives me 6, and 4 times 2 is 8, so that gives me 48. The factor pairs of 48 are 48 into 1, 24 into 2, 16 into 3, 12 into 4, 8 into 6. I think these are the only ones possible. We look at this sign, we are going to find the difference between the two. So 47, 22, 13, 8 and 2. We are looking for 13, which is this one. Negative sign means one has to be positive, one has to be negative. Negative sign here means the bigger number has to be negative. So minus 16 plus 3. Break the middle term. So 4 root 6 x square minus 16x plus 3x minus 2 root 6 is equal to 0. Now what can I do? I think I can take 4 as common. Or should I take root 2 also as common? Because 4 into root 2 into 3. No, I'll take, let's see what we get. Let me take only 4x as common and I'll be left with root 6x minus 4, plus in the second case I'll take what as common? 3 cannot be common. I can take root 3 as common. So I'll be left with root 3x and minus if I taken root 3 common, 2 root 2 is equal to 0. So you see this doesn't work because we've got different things. So probably I should take something common in these two also. so that only thing common is possibly root 2. So I can take 4 root 2 as common, 4 root 2 x. So I'll be within brackets, I'll be left with root 3x minus, if we take out root 2, I'll be left with 2 root 2 here. And now it's clear, it's 4 root 3 times root 3x minus 2 root 2. Now we see that both the things within the brackets remains equal. So root 3x minus 2 root 2 times root 3, 4 root 3x plus root 3 is equal to 0, which means if we find out the value of x should be equal to 2 root 2 upon root 3, or in this case x should be equal to negative root 3 upon 4 root 3. The root 3 gets cancelled, which means it's going to be negative 1 over 4. So simple, not very difficult, not very complicated. Let's move to the next question. X square minus 3 root 5 x plus 10. We are going to look at the product of 1 and 10, which is equal to 10 only two possible factors, 10 into 1 and 5 into 2. We look at this sign, which is positive, so we look at adding the two numbers 11 and 7, but none of them are equal to 3 root 5, so that means this is not what we are looking for. So we will have to break these factors of 2 into something with root 5, because we can see root 5 is there, or we can break the factors of 5 into root 5. So if I can say 10 can also be written as root 5 into 2 root 5. That is one of the factors. In the second one it will be root 5 into 2 root 5. Again, both are the same, so it doesn't matter which one we take. We look at this sign positive, we add the 2, we get 3 root 5. That is what we are looking for. Negative sign here means both have to be negative, so this also negative, this also negative. Split the middle term splitting method. X square minus 2 root 5 x minus x plus 10 is equal to 0. Taking x as common, I get left with x minus 2 root 5. In the second one, I take minus what as common? Sorry, this was root 5x. So I can take minus root 5 as common. I'll be left with x minus 10 as 2 into root 5 into root 5. So root 5 goes out, so I'm left with 2 root 5 is equal to 0. Now which means x minus 2 root 5 times x minus root 5 is equal to 0, which means x should be equal to 2 root 5 or x should be equal to root 5. Looks complicated, but it is not. Very simple. Let's move to the next question. Moving up, picking up speed now, and this is pretty straightforward. 1 into 30 is what we are looking for, which is 30. Factor pairs are 30 into 1 and 10 into 3 and also 15 into 2. What else? 6 into 5. We are looking at negative, so subtracting we get 29, 7, 13, 1, which is not what we are looking for. It has to be root 3 somewhere. So we break this 30 into root 3. So instead of 1, I can write root 3. What will be left with? It is 3 into 10. So it will be 10 root 3. In the second one, again root 3, bringing it here, it's going to be the same thing. In this thing, 5 into 3. So 5 times root 3 into 2 root 3. Yeah, 5 root 3 into 2 root 3. That's also equal to 30. Yes, 6 into 5 can be written as 2 root 3 into 5 root 3. Again the same thing as above, but this is what we are looking for. Difference between the two, I get 9 root 3 here, I get 3 root 3 here. Because we are looking at 3 root 3, this is what we are going to take. Negative sign means one has to be positive, one has to be negative. Positive sign means their bigger number has to be positive, so this is positive, this is negative. Splitting the middle term, I get x square, negative term first, 2 root 3x plus 5 root 3x minus 30 is equal to 0. I take x as common, I'm left with x minus 2 root 3. I take 5 as common, I'll take 5 root 3 as common, and I'm left with x minus root 3. So root 3 goes out, I'm left with 5 also goes out, so I'm left with 2 root 3 is equal to 0, which means x minus 2 root 3 times x plus 5 root 3 should be equal to 0. Pretty clear that x is equal to 2 root 3, that's one value of x, or x is equal to negative 5 root 3, that's the second value of x. Right, next question. Right, I hope you are understanding also along with me, and we are finishing pretty quickly. 4 questions now. Right, solve this. This I think we will need to factorize this first into products. Pretty simple to do that. 8 can be written as 4 into 2, and I think the difference is 8. This is positive, so a square plus 2a minus 8 can then be written as negative, can be written as plus 4a minus 2a minus 8. That should so this can then be factorized as a times a plus 4 minus 2 times a plus 4, which means it is a plus 4 and a minus 2 are the two factors. We look at this sign, which is negative, so that means we have to find the difference between the two. So a plus 4 minus a minus 2 gives us a plus 4 minus a plus 2, which is equal to 6, which is what we are looking for. Positive sign, negative sign here means one has to be positive, one has to be negative. Positive sign here means the bigger number has to be positive, so obviously this is positive and this is negative. Splitting the middle term, I get x square, the negative term first, minus a minus 2 times x, plus the positive term a plus 4 times x, minus, I break this also into factors, which is a plus 4 into a minus 2 is equal to 0. In these two terms, I think x is common, so I'm left with x minus a minus 2. In the second two terms, a plus 4 obviously is common, and I'll be left with x minus a minus 2. That should be equal to 0. I see that x minus a minus 2 is common in both of them, so x minus a minus 2 should be equal to 0, or x plus a plus 4 is equal to 0, which means x should be equal to a minus 2 or x should be equal to negative a plus 4. These are the two values of x. Pretty easy, pretty simple. Let's go to the next question. Right, again we look at the product of a and c, which is 12ab into 6ab, which is equal to 72ab square. Looking at these two, it is pretty straightforward. A square b square, sorry, pretty straightforward that the two factors should be 9a square times 8b square, because then we look at this sign, which is negative, so we subtract the 2, so we get 9a square minus 8b square, which is what we were looking for. Right, so I can probably even break this up, so I can say 12abx square minus 9a square x minus 8b square x minus 6ab is equal to 0. What is common in these two? Obviously 3 is common, a is common, so I'm left with 4b, and x is also common, so 4bx minus 3 has come out, a has come out, so minus 3a, minus what is common in these two? 2 is common, b is common, x is not common, so we are left with 4bx minus 3a is equal to 0. Yeah, so 4bx minus 3a is equal to 0, or 3ax minus 2b is equal to 0. Finding the value of x, we get 3a upon 4b, or x will be equal to 2b upon 3a. Very simple, easy to do. Next question. Find the value of k for which x is equal to 1 is a root of the equation x square plus kx plus 3 is equal to 0. Also find the other root. So the other root, obviously when we do such a question, we just take the product of the when we say that x is equal to 1 is a root, that means by the remainder theorem, when we put the value of x as 1, this whole thing, the left hand side should be equal to the right hand side. So putting the value of x as 1, we get 1 square plus k times 1 plus 3, that should be equal to the right hand side, which is 0. Or in fact, putting in the value of 1, we should get it as 0. So that is equal to 0. That means 1 plus k plus 3 is equal to 0, or k plus 4 is equal to 0, which means k is equal to minus 4. So if it's minus 4, we get x square minus 4x plus 3 is equal to 0. Looking at 1 and 3, it's going to be only one factor pair, which is minus 3x minus x plus 3 is equal to 0. Taking x as common, we are left with x minus 3, minus 1 as common, we are left with x minus 3 is equal to 0, which means x should be equal to 3 or x should be equal to 1. Pretty straightforward. Last question of the day. Yeah, so far so good. So we are looking at this, that we first have to find the factors of. So 2a square plus 5ab plus 2b square. Now this is a two-step question. So we are looking at let's look at a as the variable. So we are looking at 2 into 2b square, which is equal to 4b square. And we are going to find the factors. 2 into 2b square is 4b square. We are going to find the factors of this, which are going to be what can it be, 4b into b, or it can be 2b into 2b. We are looking at this sign here, which is positive, which means we add them, we get 5b, and here we get 4b. So obviously 5b is what we want, so we take this as the thing, 4b and b, and we are looking at this sign, which is positive, which means both have to be positive, both have to be negative. This sign positive, which means both have to be positive. Splitting the middle term, I get 2a square plus 4b plus b plus 2b square is equal to 0, which means 2a is common. Yeah, sorry, this was 4ab, and this is also ab, because a was the variable, we forgot that. So 2a is common, and we are left with 2 has come out, so we are left with a plus 4b, and in the second two terms I think b is common, and we are left with a plus 2b. Sorry, this should also be 2b, because 2 we are taken as common. So that is a plus 2b into 2a plus b. Right. Now what will we do? Sorry, there's a 9 also that we need to multiply to this. So now we look at this whole thing. So this can be written as 3a plus 6b, that is one of the factors, or 6a plus 3b. Then we look at this sign, which is positive, which means we have to add the 2, so that becomes 9 times a plus b, which is obviously what we want, and negative sign means both have to be negative. So now we break it. So 9x square minus 3a plus b times x minus 3a plus 6b, 3a plus 2b let me erase it. A plus 2b times x minus 3 times 2a plus b times x plus 3a plus 2b times, sorry, again 3 as common, a plus 2b times 2a plus b, that should be equal to 0. I see that 3 can be factorized out or divided by completely, so I left with 3x square minus a plus 2b x minus 2a plus b times x plus a plus 2b times 2a plus b is equal to 0. In the first two terms I see that x is common. I am left with 3 minus 3x minus a plus 2b. In the second two terms I see that 2a plus b is common, so minus 2a plus b, and I am left with x and and I'm left with what, x and 2a plus b, a plus 2b plus a plus 2b, which is pretty clear now that we can take x will be equal to a plus 2b upon 3, or in this case x should be equal to, or x should be equal to 2a plus b. Yeah, so these are the two values of x that should be there, and we get the value. So that's it for today, and I thank you so much for your presence in the stream today. I loved it a lot, really interacting with you, though there wasn't much interaction today, and it was good. So basically what comments, I've got no comments, just one good evening from someone. But I would request you to subscribe to the channel so that you get access to all the live streams in the future. I would request you to like the video if you liked it really, and I would also request you to go to watch the video linked in the description box, because that is really going to help you for your board exams. So with that I will end the stream now, and I'll see you next week at 5 p.m. Sunday, 9th of January. So till then, take care. God bless. Bye.